Okay, but this one is much more acceptable. Heptatuine. We put it here than the other side. Okay. So we got the next one. What's the IPAC name of compound B? Compound B is 1, 2, 3, 4. This one has no issues. So it's 1, 2, 3, 4. This, if I count from this side, it's 1, 2. If I count from this side, 1, 2, 3. So it means that I'm gonna go with that direction. So it's gonna be 1, 2, 1, 2, 3, 4. So if it's 4, it's gonna be butan, and then now direction is, we're gonna use this direction. It's 1, 2. So the functional group is on common atom number 2. So I'm gonna say dash 2. Which functional group is this? These are ketones. So I'm gonna add the one on. So it becomes but2 on. But2 on. Yes. So did you get it right? You just wrote but. Yeah. Remember when you are adding until to that point, to from alcohols, as long as it's not hydrocarbon, you write up to here. For example, if apart from hydrocarbons, ne, those ones you say but, pent, prop. But once these other groups, you say but, you reach here. Penten, then you put whatever you want to put. Pentanol, pentuol, pent, on. You see? So you add up here, it goes up here. It's only this hydrocarbon alkane, alkene, alkyne is where you stop here. But the other homologous series, we have to add up to there. Is it clear? Then we go to the next one. They are saying that compound D is a gas. Compound D is a gas, is butane, used in cigarette lighters. To which homologous series does this belong? Which homologous series? Alkanes. Then they are saying that write down the structure formula and IPAC name of isomer of compound D. So it means that if you have a butane, this is 1, 2, 3, 4. They just want to have an isomer. What you do, because this is an alkane, it can only form chain isomers. So you just cut off this, put it there, then it's done. So it means that I'm gonna have a new 1, 2, 3, and then a branch of that. Yeah. So the compound changes. So, but they said, and write the IPAC name. They said, did I say that? Functional write down the structure formula and IPAC name of isomer of D. So they want also the IPAC name. So it's 1, 2, 3. So it's prop 3, prop 2. Hey, did I say? No, 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 no. Sorry, sorry, sorry. It's propane. It's propane because it's an alkane, but it has a side group which is on carbon atom number 2. So it's methyl. Methyl is a methyl, but is on carbon atom number 2. Therefore, it's 2-methyl propane. Did you get it right? One methyl. Huh? Yeah, then it's the same thing. Did you know? Because you wrote like this. You said one methyl. It can't be. But it was like this. Uh, uh, you put it, okay, what you did is like this. Yeah, that's not a chain. It's the same thing. It's exactly the same thing like this. A chain, it must have a carbon somewhere. If you go like this, you don't stop. If you go like this, you don't stop. You see. But now, if it's just bending, it means it's the same chain. It's the same thing here. Look what we did here. You see that the longest chain, you said it goes like this. You see that this is the longest chain. It's also bending. I see. So bending doesn't mean that it's a different chain. When you sleep on the bed and you fold your legs, does it mean that it's a different person? No, it's the same person. It's just that you are folding. There is no road which is straight, 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 straight. Some roads are okay, they are straight, and others they are folding. But does it mean that the name of the road is changing? No, it's the same thing. So when it comes to this, you only talk. You see, when I go like this, I only it's the longest chain. So because this one and this one were not covered, therefore it becomes a side group. So it's the same story with this. That when it comes like this, I'm leaving this out. If I go like this, I'm leaving this out. Therefore, one of them is a side group. But if just bending, I go through all of them, then it means that it's not a side group. All right. You got it right now? Are you getting it there? Okay. We continue to the next question. Uh, the next question. So we are saying that uh, they're saying that compound D react with bromine. Whenever you talk about compound which reacts with bromine, eh, 4, 2, 3. Oh, they're saying that is isomer of this a chain isomer, position of function. They're saying isomer of two. Yes, we said is a chain isomer. Alkanes only forms chain isomers. So it's a chain isomer. It's a chain which has changed. Because at first it was like this, then after that we made it to branch. So it's a chain isomer. They are saying that name is okay. Compound D react with bromine. Whenever you talk about a compound which reacts with bromine, it's that compound which has a double or a single bond. Remember, these are saturated compounds. Saturated compounds are compounds. Saturated compounds. These are compounds which have double or triple bond between carbon atoms. You can't say that it has double or triple bond. Between where? Between the carbon atoms. Those are unsaturated compounds. Then saturated compounds are compounds which have single bond between carbon atoms. So saturated compounds are compounds which have single bond between carbon atoms, while unsaturated compounds are compounds which have double or triple bond between carbon atoms. So that's the major difference. So alkanes, they work, alkanes work with unsaturated compounds so that they convert those compounds into saturated compounds. So it must have a double bond or a triple bond. So once I bring bromine here, remember bromine is red and is a liquid. That's why they call it bromine mora, which is red. So the bromine is gonna break. Once it breaks, yes, one, even this one's gonna break. One goes here, another bromine goes there. If it was a double bond, one part goes there, another part goes there, then it means that it becomes saturated. So it converts it from unsaturated to saturated. So bromine is a compound which is used to test whether the compound is saturated or is unsaturated. If the compound is saturated, then the bromine molar, that red color, will be decolorized, meaning that it will turn from that red color and then the color will be taken out. Basically, it will turn into colorless. So they're saying that a compound reacts with bromine. The moment it reacts with bromine, it means that it has a double bond or a single bond, but it depends on the condition. To form 2-bromo-butane, meaning that it is compound D. Okay. Name the homologous series to which 2-bromobutane belong. Where does 2-bromobutane belongs? To which homologous series? Yes, because of the bromine is a halogen and the other part is an alkane. So it is haloalkane. Right. Name the type of sometimes we call them uh they call them ish. The name is gone. Uh alkyl halides. Sometimes they call them alkyl halides, meaning that remember those are halides. So it's better to call them alkane because it's simple, is you are able to remember it. Yeah. So they're saying that the type of reaction that takes place. Substitution. Why are we saying substitution reaction? Is because we are removing one, two, three, four. So we are removing a hydrogen and we are putting there a bromide. So we are substituting. So it's a substitution reaction. Then they're saying the type of, okay, we are done with that question. So question which come like this, you have to maximize the marks. You have to maximize the marks. You have to make sure that there is no way how you can go without it. So the maximizing of the marks must be there. Mhm. Then we go the next question. We go the next question. They are saying that consider the organic compound represented by letter A to C. We are representing letter A to C. What are they saying? So we can first identify the homologous series, which functional group is on each. So if you look at this, these are halides, it's a halide. So is a haloalkane. Then they are saying this one is oxygen is attached to O to this, so it is an alcohol. And then this one, it is a keton. Okay. Name the homologous series to which C belong. What is the homologous series for C? Mm, it's a keton. And what's the functional group? Mm? So you didn't read what I gave. Mm. What's the functional group for keton? It's about what? Oxygen and CO. So what is its functional group? Mm. Ca- Carbonyl. Is it clear? Yeah, they are carbonyls. They are what? They are carbonyls. So when they ask you the functional group, yes, this is the functional group. This one I've circled. It's the functional group. It's a carbonyl. And then the ketone, I mean the aldehyde, the homologous series is the aldehyde. The functional group is the formyl. So you must read that thing I send you. Mhm. We got the next one. They are saying that structure formula of the IPAC name of compound A. What did you write? Hmm, too long for no reason. 2,5. Chloro octane. Okay, let me find out. It's one, it's two, it's three, it's four, it's five, it's six, it's seven, it's eight. Hmm? Two in. You wrote two in. Chloro. Huh? Two in like this. Oh, 2,5 chloro, two n like this. Okay, let's find out. So this is the longest chain. It's octane. Yeah, oct like this. Okay. And they're saying 1, 2, 3, 4, 5, 6, 7, 8. So 8 is how do we name 8? 7 is hept. 8 is oct. Oct. Is does it have any double bond anywhere? No. So it's octane. Okay. Yeah. Now let's find out the side groups. Find out the side groups. So this one becomes a side group. However, this and this are branches. So if I count from this side, it's gonna be 1, 2, 3, 4. The first one was on 4, 4. Then you have 5. Then I have 6. Then I have 6. And then 7. No, yeah, 6. If I count, that is from that direction. If I count from this direction, I'm gonna have 1, 2, 3, 3. Then this one's gonna be 4. Then this one's gonna be 5. So when I add here, it's gonna be 9 plus 3, which is 12. When I add here, it's gonna be 9 plus 6, which is 15. So it means that I'm gonna go with this direction. So now once I get the direction, Marami, go for your answers. Once I get that direction, now I start to count properly, isn't it? Because I've found out the what? The direction. Okay. So we say that the first one, we say that is octane. Then since I'm using this direction, I'm going to have 1. So it's 1, 2, 3. So it's going to be 3 chloro. But I have another branch here. 1, 2, 3, 4. which is a methyl. So it's gonna be 4-methyl. Is it? Then I'm gonna have 1, 2, 3, 4, 5. I have another chloro at 5. So 5 chloro. Isn't it? Are you there? So now I have to add them. C and M, which one is first? It's C. So I have the first chloro is on 3, the second chloro on 5. So I'll come here, I'll say 3, 5. Chloro. Yes. Remember there are two of them. It's this and this. Who we have to describe it. Who means die. So it becomes di 3, 5 dichloro dash. Then I come to now to the methyl. 4-methyl octane. That's it. It's 3, 5 dichloro 4-methyl octane. Why don't I put 2 somewhere or what? Because a single bond cannot be shown. The single bond throughout is a hydrocarbon, sorry, is a saturated compound. Are you getting it? Here or there. Yes, it's long because I said it's long for no reason. It's long like that. Okay, for step 1, first find out which one has the shortest. Okay, step 1, first identify the longest chain. We have identified the longest chain as this. So after identify the longest chain, okay, we have identified the longest chain as that. Sorry. We have identified the longest chain as this. Step 2, you name it. So we named it as octane. Yes, because single bond. Step 2, identify the side groups. So we have seen that we have 3 of them. So identify the shortest route. If I go like this, when I count them from this, I get 3, 4, 5. The first side group is on 3, the second one is on 4, another one is on 5. When I go like this, when I count from this side is 1, 2, 3, 4. The first one is on 4. The second one is on 5. The third one is on 6. So you see that now this one, when I add them, it's going to give me 15. While here, when I add them, it's going to give me 12. 12 is less than 15. So I'm going to take that route instead of this route because this one is too much. I was doing that so that I identify the shortest route. So once I get this, now I start to label them. That this one is on carbon atom 1, 2, 3. It's on carbon atom number 3. It's a chloro. All right. It's 3 chloro. Then the second chloro is on carbon atom number 5. You see, that's why I come here, I say that 3, 5. But because there are 2, therefore I say it's di. If there are 3, then I will say tri. So there are 2, therefore I say di. Dichloro. Then what is the methyl? Where is the methyl? It's 1, 2, 3, 4. It's on carbon atom number 4. That's why I said here, dash 4-methyl octane. Why did I start with the chloro, not the methyl? It's because C is nearer in the alphabetical order than M. I use C because this is just a description, which means it's 2. So you have to use its own name, which is a chloro. C is before M. in alphabetical order. Therefore, that's why I started with this. So they just brought it so that you confuse, it you are confused, but it's not that bad. You understand? Are you there? Yes, sir, I understand. Right. Then we go to the next question, which is the structure formula of a tertiary alcohol is an isomer of compound B. The structure formula of a tertiary alcohol is an structure isomer of compound B. Uh, Structure formula of tertiary alcohol is a structure isomer of compound B. Where's compound B? It's here. They're saying write down the structure formula or write down the structure formula of a tertiary alcohol. So because I want to convert this into a tertiary alcohol, so I need to find out how many are they. 1, 2, 3, 4. So I have 4 carbon atoms. So if I have 4 carbon atoms, I just have to distribute it so that this carbon atom has no hydrogen. So 1 carbon, 1 carbon, 1 carbon, and then OH, meaning that it's 1 carbon, 2, 3, 4. Those are the 4 carbon atoms, 1, 2, 3, 4, because they said it's a tertiary alcohol. So tertiary alcohol, yes, the carbon atom with a functional group, yes, is attached to 3 other carbon atoms. You see, 1, 2, 3. So I just put the hydrogens there, and then the structure is done. The structure is what? The structure is done. Ah, that's what they wanted. Did you write it like that? It can't be open because why? Because if you write it in a different angle, it means that the alcohol will not be, this carbon will not have 3 carbon atoms attached to them. Remember, a tertiary alcohol is an alcohol whose uh, carbon with the functional group is attached to other 3 carbon atoms. You see, that's why it's called a tertiary alcohol. Then they're saying that alcohol and the methanoic acid are heated in presence of concentrated sulfuric acid to form an ester. What is the role of sulfuric acid? Whenever they ask you about the role of sulfuric acid is acting as, it acts as a catalyst. A catalyst. So it produces hydrogen ions as a what? As a catalyst. Then I say write down the name and the formula of organic product formed. Name and the formula of organic product formed. So when you talk about organic product, then you're forming ester. But now we have to write it down. You have to write it down. what we are saying. So let's look at this question. Are you there?
Yes, sir.
Okay. They're saying that. Let's look at this question. What are they saying? Saying that what's the role of sulfuric acid? We said it's a catalyst. Then they're saying that write down the name and the formula of organic product formed. So what reacted? They said an alcohol and methanoic acid are heated in the presence of sulfuric acid to form an ester. It forms an ester. So they are not specific which alcohol. So it means that you are using the alcohol B. Oh, alcohol B. Okay. They're saying that an alcohol and methanoic acid is heated in the presence of concentrated sulfuric acid to form an ester. Then they are saying that write the role. What's the role of sulfuric acid? In this case, the role of sulfuric acid, we say that the role of sulfuric acid is to act as a catalyst. So now, since we are using this alcohol, so now we need to find out it's 1, 2, 3, 4. So this process, remember, is called esterification. So I have 1, 2, 3, 4. Then alcohol. Okay. So remember, these are hydrogens. Just for the case of time, I might not put them all. But if in exam you don't put them, you're gonna get it wrong. So I form ester there. Once I form an ester, sorry, it's an alcohol. So this one is done. I'm gonna react it with methanoic acid. Methanoic acid has only one carbon. So plus methanoic acid. Methanoic acid is like that. So it means that I'm gonna have one hydrogen and then uh, yes, 1, 2, 3, 4. So it looks like that. Ne? These are just, I'm counting the number of bonds. Supposed to be 4, 4. It can be, this thing can be facing up. And for the case of reaction, you can even change it in that angle. And we say that is OHC double bond OH, like that. So that now what happens, remember alcohol loses the oxygen, hydrogen. Sorry, carboxylic acid loses the oxygen and hydrogen, while alcohol loses the hydrogen, like that. So this one is gonna form H2O. The moment it forms H2O, yes, it forms an ester. Remember, we have a sulfuric acid acting as a catalyst. So it means that I'm gonna have 1, 2, 3, 4. Yes, now this. Let me just do like this. This oxygen, then combined this. Uh-huh. Yes, then hydrogen. So you see how it looks like. So it means that this is which came from methanoic acid, while this came from alcohol. So this with the hydrogens on them is what you call ester. And this ester has a fruity smell. This process is called esterification. Esterification. It's called esterification. So what is the question? They are saying that write down the name and the formula of they're saying formula. Name or formula of inorganic product. So first of all, they're saying that right is what is the function of sulfuric acid? So we got it. It is sulfuric. It's acting as a catalyst. They are saying that write down the name of formula of inorganic product formed. Inorganic product formed is H2O. We have seen it. You can say water here or H2O. When they say formula, use a formula. When they say name, use the name. If they say either way, it's fine. So you have to take note of that. Should we continue? Are you the- Oh, much more acceptable. Okay. Then we go to the next question. What are they saying? They are saying that write what is the role? Oh, you're done with this, ne? You're done with this. So you see, even they didn't ask you the formulas and stuff. At least I was just trying to show you if, because the next time they might not bring this. The next time they might ask you to write the structure formula of the product. You see? So you write that. So now they're asking the second another question. They're saying that S yes is water because water is inorganic. This one. H yes. I was going there to show you the process of esterification. But how did the water come out? It came out here. That's what they wanted. This is H2O. That's all. Even the mark is how much? How many marks there? It's one mark. Yeah. Then we got the next question. They say ester contains 6 comma hydrogen 40%, carbon and 53%. Right. Okay, do I have a calculator here? Okay. All right, let's do it. They're saying that hydrogen is 6,7. 6. So I'm gonna write the elements. Elements have carbon, hydrogen, oxygen. So they're saying elements. So atomic mass for carbon is no, not atomic mass. Mass for carbon, they said what? Carbon is 53.33. 53.33. Hydrogen is 6,67. 6,67. And then oxygen is here. They're saying that this is for hydrogen. This is carbon is 40. So carbon is 40 here. And oxygen is 53,33. Then yet carbon is what? It's 40, isn't it? Percent. Based on this one goes to that. Okay. The molecular mass is 60. Determine its empirical formula and then molecular formula. Okay. So now I need to know the atomic mass. Atomic mass for carbon is 12. Atomic mass for hydrogen is 1. Atomic mass for oxygen is 16. Therefore, to get the number of moles, I have to say mass over molar mass or atomic mass because it's one atom. So it's going to be 40 out of 12. No, I don't need to convert it. It can be in percentage, it can be in mass, it can be whatever. You don't need. You don't need. You don't need. It's the same thing. It's the same thing. Even if you do 100, it's still gonna go back because all of them are in percentage. Unless one was in the other way and then this one, you understand? All of them is in the percentage. So it's going to be 6,67 divided by 1. It's going to be 53,33 divided by 16. Once I get that, then I don't know how much is that. So let me just check on the calculator. 4 divided by 12. It gives me 3,33. 3,3. Yeah? Yes. And then 6,67. Okay, this one is the same thing. 6,67. And then this 53. 53 is gonna be what? It's gonna be 3,3. 3,33. Isn't it? So now I need to divide with the simplest. 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 So it's gonna be 3,3 divided by 3,3, which gives me 1. It's gonna be 6,67 divided by 3,3, which gives me 2. And then it's gonna be 3,3 divided. Which one? It's 2,0. It's the same thing. It's the same thing because we are looking for, we have been taking two decimal places. So if you take it, it's fine, but you see that it's approximately 2. Then this one is going to be divided by 3,3. So it's going to be also 1. So basically, it's going to be 1 carbon. Yes. Hydrogen is going to be 2 of them. And then oxygen is going to be 1. So this is the empirical formula we are looking for. You understand? So, but now the question is asking, so empirical formula, so that's why you see it is 5 marks. So they distribute it accordingly. Then now they want the molecular formula, they want the actual molecular formula of that compound, which is an ester. So we will find out that that ester will obey this if they use that alcohol. So, okay. So let's go to the, so we have got this. Now we have to put this. Okay, let me just write it here down. CH2O. This is what we got. Let me equate it. It's equal to, what is the molecular formula? They say the molecular mass is 60. Is equal to 60. You understand? So I need to find out what is N. So I'm gonna say carbon. Is it 30? Okay, I don't know. I want to find out. Carbon is 12 plus hydrogen is 1 times 2 plus oxygen, which is 16. So this is when you add, it's gonna be 14 plus 16, which is equal to 30, isn't it? All this is N, which is equal to 60, which is equal to 60. So it means that 30, which means 30N is equal to 60 divided by 30 divided by 30. So N becomes 2. So therefore, I will come here and I say that it is C because N is 2. So this time is 2. So it's going to be 2. And then this, so it's going to be 4. And then this is going to be 2. Isn't it? So if you draw it, you'll find out that it is an ester. It is what? It is an ester. So it means that they used methanoic acid and the ethan and the methanol. They used methanoic acid and the methanol. That's why you see you have 1 carbon atom from alcohol and 1 carbon atom from, yes, but they didn't ask you those questions because the question was just open. It was just open. They said that an ester. They didn't mention anything. Where is the ester coming from? They didn't talk about where is the, which alcohol they use, which carboxylic acid they use. So basically, that's how you're supposed to do the calculation. Have you got it? Okay. So let's go to the last question here. Mm, they're saying that the structure formula, write down the structure formula of methanoic acid. The structure formula of methanoic acid, we saw it. It's that. This one's on there. That is methanoic acid. It's like, it's like that. So when you draw it, it becomes that, the structure formula. The IPAC name, the IPAC name of the ester. Oh, they want the IPAC name of this ester. Remember, it's methanoic acid, ethanoic acid. So if it is, we are going to use this as IPAC name. So it's gonna be methyl. Remember, esters they end with oet. Ne? So it's gonna become methyl, methanoate. Methyl methanoate. Because if you draw it, it's gonna be C. Yeah, so that ester is gonna look like that. 1, 2, 3, 4. So 4 hydrogens. You see, these are the 4 hydrogens. And then 2 carbons. 1, 2, 2 carbons, 2 carbons. And then 2 oxygens. 2 oxygens, which are the 2 oxygens there. Yeah. So we just need to practice more questions. And these questions sometimes you know that, no, that topic I know. Uh, Mina, I have a principle that you start with a topic you know, read it, grill it, let it be in your blood. Even if you're going to specialize, at least you know that, yeah, when it comes to organic, yeah, you can kill it. If you're going to specialize maybe in electrolysis, you know that topic, you like it too much, yes, kill it. Must not be question which you can't answer, or you can answer it but doesn't give you headache. But if you just put this one, I know, but sometimes they bring question and then you go off. And then even the other ones you think they are hard, you can't answer, so you end up failing the paper. At least you know that this one, whenever you practice thousands of questions, as you go to also another one, then by the time you write, things will be easier for you. So, this part of organic, I think we are done with it. We are done with that. So, the next part of organic, I think I should talk about the last part. I might not talk about it today, but I'm going to give you questions to practice for me so that when I come back, you can do them. These physical properties. Then the moment we finish physical properties, we got the next what? Got the next topic. We will finish, as I always say, that we will finish. Let me drive. Let me drive. We will finish and we will enjoy. Just read, practice those questions you have not answered, we have not tackled. When you reach to those topics, yes, you have those ideas. Yes, make sure that I'll show you how you can tackle them so that you go through them without too much stress. But I know that we'll what? We will finish. Unless you have a question. If you don't have a question, we're gonna stop here. I don't have a question too. So I'm gonna send you the questions for you to practice. After that, at least when we come back again for the next class, please come back when at least you are ready. Sure, sure.